Okay, hello. Good evening. Is my voice audible?
Yes, sir.
Yeah. So, is the screen visible now? Great. So, is the audio quality satisfactory? Is there any background noise of the fan? Yes, Tanish, please unmute yourself and answer.
So,
Okay. So, as per Sure. Okay, so let's continue with the class. The homework of the class was to remember this slides formula and like trigonometric basic formulas and also of the slides. And the slides, you have to just understand these formulas. After you have learned the formulas of these two slides of trigonometric formulas, then you will be able to understand these formulas very, very easily. Okay. Okay, so I believe that this chapter is clear to you. Is there any doubt? Is there any doubt regarding the previous videos, previous lectures? Okay, so let's proceed further then. Okay, so let's discuss this chapter discussion. So we have to find out the derivative of an inverse trigonometric function and this certain expression given inside this inverse trigonometric function. So first, what we have to do is we have to simplify this given function, and we can do so by using our formulas which we have seen earlier. So here we have a form of simple square root of a plus x. The degree of x is 1. So it is in the square root. So here we can see here the degree of x is also 1 and e can be 1 here. So let's put x is equals to cos theta in this situation because we also know earlier that like 1 plus cos theta is 2 sorry 2 cos square theta by 2. It is derived from using double angle formula of cos 2 theta, which says cos 2 theta is equals to cos square theta minus 1. Okay. So if we will write this formula and we'll modify this formula and we'll replace 2 theta by theta and theta by 2, then we will be getting this form. So here we can substitute x for x is equals to cos theta. So on doing so, this particular function will become square root of 1 plus cos theta plus square root of 1 minus cos theta upon 2. Okay. Then on proceeding further, as we know 1 plus cos theta is 2 cos square theta by 2 and 1 minus cos theta will be 2 sine square theta by 2. Simplifying the function further, 1 plus cos theta is 2 cos square theta. So if we will just square root this, so it is coming out to be square root of 2 into cos of theta by 2 plus square root of 2 into sine of theta by 2 because the square has cut it or they cancel the effect of square root, okay, by 2. We can take root 2 common, sine inverse. So if you will just write this to individual like separatively with this term and this term. So square root of 2 by 2, it will become root 1 by root 2. Yes, are you able to understand this? Why it is so? Because 2 is what? We can write 2 is as root 2 into root 2, root 2 square, okay? So that's why if we will do this, then 1 root 2 will cancel 1 root 2 and it will come out as 1 by root 2, okay? Is that clear? Please unmute yourself and answer, otherwise I'll mark your attendance in the class as absent. Okay.
Yes, sir.
Yeah. Please keep keep responding so that I believe that some humans are there in the class. Yeah. So it will become 1 by root 2 into cos of theta by 2 plus 1 by root 2 into sine of theta by 2. Now we can see that this particular situation is similarly like when we will expand sine A plus sine B, it comes out to be what? It comes out to be sine A cos B plus sine B cos A. So here we can take the value of cos B as where we can take B as theta by 2 and we can write 1 by 2, 1 by root 2 as sine 45. Or what is sine 45 in radians? It is pi by 4. And 1 by root 2 we can also write it as, if we have to write it and write it in the form of cosine, so we write as cos pi by 4 here. So comparing this formula with our given expression, A will become pi by 4 and B will become theta by 2. So now we can write it as sine inverse of sine of, where A was pi by 4 and B was theta by 2. And now we know sine inverse will and sine, the inverse trigonometric function and the trigonometric function will cancel each other's effect. After doing so, it will become as pi by 4 plus theta by 2. Now theta is not in the given options. We have to further substitute theta with x. So from this, we can write theta is cos inverse of x, right? So it will become pi by 4. Let's use another slide. Pi by, okay, pi by 4 plus theta by 2, as theta is cos inverse of x. As theta is cos inverse of x. I guess now it should work fine. No. Okay, so now we can proceed further with solving this. And my laptop is not responding. Now I believe it will work. So pi I so I guess now it should work. Yes, pi by 4 plus theta by 2. As earlier we see that theta is what? Cos inverse x as per our assumption, because we have earlier letted x as cos theta. So now we are reversing our assumption, and x was cos theta. So theta is what? Cos inverse of x. So now pi by 4, sorry, pi by 4 plus theta by 2, which is cos inverse of x by 2. Now let us try to match our options. So till now we have done only this thing, that we have simplified our function, which was what was our function? Sine inverse of square root of 1 plus x plus square root of 1 minus x by 2. So this was our function, and we have just simplified it and written it as in this form. Okay, successfully. Now we will derivate it on differentiating the function with respect to x. Pi by 4 is a constant, so its differentiation is coming out as 0. And the differentiation of cos inverse of x by 2 will be what? Uh, as it is c in the starting, so it will be in the negative square root of 1 minus x square. What is x here? X by 2 square into the derivative of the function which is inside this inverse trigonometric function, which is x by 2. The derivative of x by 2 is what? Please unmute yourself and speak. Yes, Rishi. Yes, Tanish. What is the derivative of x by 2 with respect to x? You have to unmute yourself and speak. What I'm asking is, what is the derivative of x by 2 with respect to x? You will not be able to learn if you won't do mistakes, okay? So don't be shy that you will give a wrong answer. At least try. Please unmute yourself, otherwise I'll have to mark your attendance as absent.
So 1 by 0.
1 by 0, okay. Yes, Rishi, do you have some other answer? Okay. So, what is a function here? Let us say, let's use some other alphabet. Let's say g of x is x by 2. X by 2 can be written as half into x. And if it is a constant, so we can just put a constant separately. And when we'll have to derivate this function, when we'll have to differentiate this function. So half will be just written ahead, and then x will be derivated or differentiated. So the differentiation of x is what? 1, right? So z of dash x will be half. Okay, is this clear to everyone?
Yes, sir.
Is this yeah, great. So here the differentiation of x by 2 will get multiplied using chain rule. And please watch earlier lectures. If you have missed those in the live class, you can watch them on the in the playlist and on the YouTube. Okay. Further solving this question, 1 by 2, 1 minus x square by 4. Right. So taking LCM 4 of 4, 4 minus x square then the denominator 4 will become square root of 4 in the numerator. Square root of 4 is what? That is 2. So 2 will cancel 2. It will come out as 1 minus 4 minus x square. So are we missing on it? Let's review our calculations. Cos inverse of x by 2. So what is theta? Array, yes. Theta is cos inverse of x, and we have applied by 2 on its angle. This is completely wrong. Theta is cos inverse of x, and we are multiplying x by 2. No, we have to multiply whole of cos inverse of x. That is why half will remain here, and cos of inverse derivative, which is directly 1 minus x square, will be there. So you have done a little mistake here. Let's my laptop is not responding. Anyways, okay, pen is working. So यहाँ पर we had not to write 2 here. So it simply will come out as 1 by 2 into square root of from next time I'll save this file in my SSD, which is in which the Windows is installed. So I guess that will boost the speed. Yeah. So half is just a coefficient with the function. So we have just separately written half, and then we have to multiply the coefficient, the derivative of cos inverse of x, which will come out as 1 minus x square. The answer will become minus of 2 into 1 minus x square. This is our answer. Okay, so yeah, it is matching with option number B. Any doubt, anyone? No doubts. So shall we move ahead? Great. So let's come on the discussion of next question. And please be like, don't be very get very scared after seeing these questions. These are very easy questions. You just have to have uh, prior knowledge of formulas, of inverse trigonometric formulas and trigonometric formulas. And mark my words, the trigonometric formulas are so important that they are going to be used in while solving questions of like most of the chapters. Okay, so you have to learn them today or tomorrow if you want success. Okay, in your NDA examination. I'm not saying about other things. Yeah. So after seeing this function and this function, whenever we see inverse trigonometric function, we have to solve for its derivative. What we have to first do is that it's better to simplify it. So let us consider this function as u of x. So u of x is tan inverse 1 plus x square minus 1 upon x. So as it is in the form of 1 plus x square, so we can put x is equals to tan theta. Why? Because there's an identity, 10th class identity, which says 1 plus tan square theta is equals to sec square theta. Okay, so 1 plus x, this will become sec theta for remember this, that we have assumed x equals to tan theta. So u of x will become sec theta minus 1 upon tan theta. Okay, now we know it very well that sec theta is what? 1 by cos theta, and tan theta is what? Sin theta by cos theta. So now we have to simplify it further. And it would be better if we can solve it for some value of tangent, so that inverse trigonometric function of tangent will cancel the trigonometric function of tangent. Okay, let's do it step by step. And in exams, you will be doing it very fast, only provided that you have done enough practice. Practice is the game. So sec theta will become, let's just now solve this, the function which is inside this inverse trigonometric function. Sec theta is 1 by cos theta minus 1. This is sin theta by cos theta. Cos theta LCM in the numerator, 1 minus cos theta by cos theta into sin theta by cos theta will get cancelled, will become 1 minus cos theta upon sin theta. Okay, is this clear, everyone? So what we have done till yet, u of x is 1 minus cos theta upon sin theta. Now, as per our earlier discussion also, and as is, it is in the formula, 1 minus cos theta is what? 2 sin square theta by 2. And sine of 2 theta is what? 2 sin theta cos theta. And we have to find for the value of sin theta, so we can just divide the angle by half. The formula will become 2 sin theta by 2 into cos theta by 2, right? Okay, so u of x will become 1 minus cos theta is what? 2 sin square theta by 2 upon 2 sin theta by 2 into cos, sorry for the bad handwriting, 2 sin theta by 2 into cos theta by 2. 2 will cancel 2, sin theta will cancel sin theta here, and it will come out as sin theta by 2 upon cos theta by 2, which is tan theta by 2. We have simplified u of x. Sorry, it's not u of x. There was also tan inverse. So what happened? There was also tan inverse, which we have just for better purposes, we ignored writing tan inverse here. Okay, you understand that why have we done earlier? Tan inverse was also there. So here was also there tan inverse, tan inverse, tan inverse, and here tan inverse. So tan inverse will cancel tan and will come out as theta by 2. What was theta? Theta was tan x. Sorry. What was our assumption related to x? X is tan theta. So theta is what? Tan inverse of x. Simple. So here it will become half into tan inverse of x. Ux is this. So we have simplified ux, and if we see on the in the question that there is a ux and we have to derive this ux with respect to, let's say, vx. Okay, so let's now first differentiate ux with respect to x, and then we will divide the denominator, or sorry, divide the derivative of ux with with the derivative of vx. So let's now differentiate u of x with respect to x, and it will become half into 1 by 1 plus x square. Great. So let's now discuss about v of x. Is this clear, everyone? Till yet, is everything clear? Everyone? Okay. 2x to 1 minus x square on 1 minus 2x square. Okay. So here we can see there's an equation of square root of 1 minus x. This is a term used in the function that we have. So we can put x is equals to sine theta, because simply we know 1 minus sine square theta is cos theta. So let's just put x is equals to sine theta. So it will make it as simply cos theta, right? So v of x is tan inverse 2 sine theta into cos theta, as we discussed earlier, why it is so. 1 minus 2 sine square theta. Now we know that 1 minus 2 sine square theta is what? Cos 2 theta, right? So v of x is tan inverse. Now 2 sine theta cos theta is the formula of sine 2 theta. So sine 2 theta divided by cos 2 theta. And if we make tan inverse of sine theta by cos theta is tan theta. So it makes it as tan 2 theta. Inverse trigonometric function will cancel trigonometric function. So v of x comes out to be 2 theta. Now, as per our assumption, theta is sine inverse of x getting multiplied by 2. So let's now differentiate v of x with respect to x. So on doing so, the derivative of sine inverse x is 1 minus x square. So now we have u or v dash of x. Now we have u dash of x. Let's just divide them because it was asked to different the we have been asked the derivative of this with respect to this function on x is equals to 0. Okay, so we can simply put x is equal, we can simply put x as 0. So here if we will put x as 0, so what will um we what will it become? It will become 2 into 1 minus 1 0. So it will become 2. Okay. What about u dash of 0? U dash of 0 half into 1 plus 0 is half. Okay. So on putting half divided by 2, it will become 1 by 4. Let us see if it matches any option. Yes, it too. So the B is the correct answer. Let me repeat what we have done in this question. We have simply had to find out the derivative of this function with respect to this function. So what we had done, we had first simplified ux and vx. Then we have taken their derivative. And after doing so, we have substituted x with 0 because it was asked at 0. So u dash 0 on v dash of 0. This is what we had to find out. Is this clear, everyone? Any doubts? Any doubts? You can unmute yourself and ask otherwise you can unmute yourself and tell that you don't have any doubt. Okay, let's proceed further. Now, this is a simple property that if there is a determinant given, if there is a function given in the determinant form, then if we have to find out the functions or the given determinants differentiation, then we have to just simply differentiate the determinant row by row. Okay, first we will differentiate row number first, then we will get add it with the derivative of row number second, and then the row number 3. Okay, you can just read this particular line and you'll be able to understand it. Okay, this minute mistake made us to calculate this long. Okay, let's move on to our next concept, which is the last concept of successive uh, of the last concept of differentiation, which is successive differentiation, which is that if we have to differentiate any function for like multiple number of times, what we are discussing about it here, there is different order of differentiation. So if there's a function like this, 3x cubed 2x square plus 1x into 0. This is a function like this. So If we will differentiate it one time, like f dash of x, we are saying it as it is a y. So if we are differentiating it, dy by dx become 9x square 4x plus 1 and plus 0. So this is first order derivative. First order derivative. If we have to differentiate it further with respect to x, then it will become second order derivative. And we will represent this as this, and we have to apply double apostrophe on f. I'm just here uh, telling about the representation of both, like writing f dash and dy by dx. You don't have to do it. I'm just telling you to understand. I'm just showing it to you how it is represented. Then we will further differentiate with respect to x. It will become 18x plus 4. Okay. This is known as second order derivative. Now, if we will differentiate it further with respect to x, then it will become a third order derivative. It will come out as 18x. Sorry, it will just come out as 18. This is third order derivative. So here we can see the arbitrary constants were 3. Okay, there were 3 arbitrary constants. So here we can see 3 arbitrary constants were there. And we had to find out 3 orders, 3 order derivative, right? So I guess you may have come to know the idea of that we have to we can differentiate a function multiple number of times, and that n will be representing like this. So these are like some observations and observational formulas. You have to remember these. This is important, and this is also important, and this is also uh, not that much important. This is also important. This is also important. तो ये भी याद कर ही लेना. Remember this two only, because let's not leave this one only. So you have to remember all these formulas and the psyche behind them, that we are differentiating this particular functions n number of times, and the answer, the derivative will come out as n factorial. Okay. So is this concept clear, everyone? Is this concept clear, everyone? Please unmute yourself and speak. Okay. So please unmute yourself so that we can conclude our class or take doubts. Is everyone there? Is anyone there? Okay. Yeah. Is there any doubt? Except
sir.
this question, except this determinant question. I'll bring its solution yesterday. Sorry, tomorrow. Okay. So let's conclude the class then. Thank you, everyone. Jai Hind.
Jai Hind, sir.